Hello learners, welcome to Education Online program. I am teacher Willa Lucia. We've been looking at, in our previous lesson we were looking at the pressure law, where we say the pressure of a fixed mass of a gas is directly proportional to its temperature when keeping the volume constant. So we say that when you're plotting the graph of the pressure law, it is a straight line from the origin. So today we shall be looking at the equation of state. With the equation of state, you see that we've been talking about three laws. So this equation of state here combines all the three laws into a single mathematical formula. So when we talk about this equation of state, we are talking about the expression of the relationship between the temperature, the mass, the temperature, the pressure, and the volume of a gas. So what is this formula? You see that the formula is saying that the pressure, the product of the pressure and the volume over the temperature will give us a what? A constant. So you see, with all this, you see that the three laws are actually all combined here. The first law, where we are saying the Boyle's law, is what? With the Boyle's law, we are saying the product of the pressure and the volume is what? Is a constant. Where we are saying that the pressure is inversely proportional to the volume when you keep what? When you keep the temperature constant. So you see that it is here at the top of our formula here. So if you come to Charles' law is telling us that the pressure is being kept constant. So the volume and the temperature are proportional to each other. So you see all the three have been combined in a simple formula, which is the PV over T is equals to constant. So you see that if you have the pressure, the volume of that gas, and the temperature at the start of your experiment, you will also have different temperature and pressure plus the volume at the end of the experiment. So that means that we shall have our P1 V1 over T1 is equals to the P2 V2 over T2. So with that, we are saying that this P1 so if you look at that, the P1 becomes the temperature, the pressure at the start, likewise to our V1, which is the volume at the start, we also have this T1 standing for the temperature at the start. So you see, these ones that are carrying 1 at their lower ends is the temperature or the volume or the pressure at the beginning of your experiment. So these that have the P2, the P2 stands for pressure at the end. What is the pressure of this gas when you're bringing the experiment to the end? What value of this pressure did you measure at the end there? So you see that because of their variation, that's why you're having it, instead of having it as P1, since the values are not the same, we have it as P2. Also the T2 stands for temperature at the end. So this is what we are going to be using in our calculation. If we look at the P2, we should be knowing that is the pressure at the end of the experiment. So let's take a look at this example here. We're saying air in a 2.5 liter, air in a 2.5 liter vessel at 127 degrees Celsius exert a pressure of 3 atmosphere. Calculate the pressure that the same mass of air would exert if contained in a 4 liter vessel at negative 73 degrees Celsius. Let's take a look at our question again. Saying that air in a 2.5 liter vessel at what temperature? At 127 degrees Celsius exert a pressure of 3 atmosphere. So you see now, you're now seeing the temperature and the pressure at the start of your experiment. Now here they're telling us to calculate the pressure that the same mass of air would exert if contained in a 4 liter vessel. So you see now, the mass here they are bringing us so that we know the volume of this gas. We want to find the pressure it is exerting. So what is the volume at the start? So at the start you see that the volume of this air is 2.5 liters. So we shall have that will be our V1, which is 2.5 liters. So now that is the temperature at this pressure here. So you see, when you introduce the temperature of 127 degrees Celsius, the gas, which is 2.5 liters, will exert a pressure of 3 atmosphere. So when we introduce this temperature T1, which is 127 degrees Celsius, we shall have a pressure of 3 atmosphere being exerted by the air. So the question is telling us to find the pressure that the same mass of air would exert if contained in a 4-liter vessel at this temperature. So now, if your air, this air of the same mass, is now put in a 4-liter vessel at a temperature of negative 73 degrees Celsius, what will be the pressure that this air will exert? So we are saying at our pressure 2 is what we don't know, when the temperature introduced there is a negative 73 degrees Celsius. So at what volume? When the volume of the vessel is 4 liters. So now we apply, we have the volume, we have the temperature, we have the pressure. So meaning here we have to apply the equation of state, because we cannot apply Boyle's law here, the equation, because in Boyle's law we have the temperature as constant, but here we are seeing that the temperature keeps on varying. We cannot apply the Charles law. Why? Because Charles law is telling us the pressure has to be kept constant, but here you can see that the question is telling us that the pressure kept on varying. From pressure 1, there was pressure 2 attained. We cannot also use the pressure law, because the pressure law is telling us the volume should be kept constant. But look at our question. The volume at first was 2.5 liters, and then we have a volume of 4 liters. So there was alternation of the volume, so we cannot apply that. But then we can combine all the 3 laws to work out our question here. So that is the equation of state, which is saying that the product of pressure and volume dividing by the temperature will give us what? Will give us a constant. So we have the pressure at the start and we have the pressure at the end. Likewise to the volume and the temperature. So we shall have our P1, V1 over T1 is equals to P2, V2 over T over T2. So what is our pressure at the start that the air exerted? So you see that the air at the beginning produced the pressure of 3 atmosphere. So we shall take this 3 and substitute it in our formula here where there is P1. So you come to also the temperature. The temperature is telling us it is 127 degrees Celsius. So what happens with degrees Celsius? We have to convert, we use the absolute zero temperature to convert this from the Celsius scale to the Kelvin scale. So we need to first convert the temperatures to the appropriate scale before we substitute it in our formula. So now like this, which is 127 degrees Celsius, what shall we have? Instead of having 127 degrees Celsius, we shall add the value of the absolute temperature, absolute zero temperature, which is 273, to convert this. So let's first convert our temperatures. We shall have converting this will give us, we shall write our temperature, but our T1 is equals to, we have 120 27 degrees Celsius. Then we add the value of the absolute zero temperature, which is 273. This will give us the value on the Kelvin scale. So if we have that, what will be our temperature 1? We shall have it as we have 127. We are adding 273 to it. We shall have 3 plus 7, which will give us 10. We carry 1. We have 3 plus 7, which will give us 10. We write 0 and carry 1. Then we have 1 plus 1 and plus 2, which will give us 4. So that means that our first temperature on the Kelvin scale will be 400 Kelvin. Even the temperature at the end was given to us on the from the Celsius scale. We also convert that to the Kelvin scale. We shall have our T2 will give us, instead of having negative 73 degrees Celsius, we shall have negative 73 plus 273. So it is more or less like subtracting your 73 from 273. This will give us what? 200 Kelvin. Now we have converted it to the standard temperature unit scale. So we can now substitute what we have into the formula. So meaning we shall have now V1 and then V1 over T1 will give us P2 V2 over the T2. Our P1 is the temperature at the start, which is 3 atmosphere. We are multiplying it by the volume at the start, was 2.5 liters. So we have our 2.5. Dividing it by the temperature at the start was 127 degrees Celsius, but when you convert it, we shall have 400 Kelvin. So we are dividing it here by 400. So this one will give us our pressure too. The pressure that the air exerted when the temperature was varied has not been given. It is what we want to find out. So we want to find out how the gauge reading was. But then we have the temperature, which was negative 73 on the Celsius scale. But then now it is 200 Kelvin. So we shall have our pressure too. We are multiplying it by the volume now, which is 4. Then divide through by the value of the temperature on the Kelvin scale, which is 200. So now, okay, now if we have our 3 multiplying by 2.5, before we cross multiply, we can reduce the denominators. You see that 200 will divide 400 twice. So you see that we shall have 3 times 2.5 divided by 2 is equals to P2 times 4. Then here is dividing it by 1. So here we are dividing this because we reduce the denominators. We shall have now 3 times 2.5 equaling to, we can cross multiply. This will multiply by 3 times 2.5 multiplying it by 1 will give us 3 times 2.5. Then we want to multiply this by 2, because here we shall first have our the P which is having its coefficient as 4. So this will give us 4 P2, but then we have to cross multiply. That means we are multiplying it by the 2 here. So if we are multiplying it by this 2 here, what will it give us? we shall have 3 times 2.5 equaling to 4 times 2, which will give us 8 P2. If it gives us 8 P2, what of 2.5? When you multiply it by 3, what shall we have? So if you multiply 2.4, I mean 2.5 times 3, and then divide it by 8, which is the coefficient of the P, we shall have our P2 will give us 1.08. But then we have it as 1.0 what? The atmosphere, because it is the SI unit of our temperature. We are trying to find the pressure we want to find. So you see that when they have given you all these elements here, all the properties in your question, it becomes so inappropriate for you to pick one of the laws so that you work out such numbers. So combining all the 3 equations would give you an appropriate formula for working out such a number. So this is what we get, because here you see that they have given us the temperature at the end and the volume at the end, but then because they wanted us to find the pressure. So if we apply this formula, you see that it becomes very simple for us to get the temperature, the pressure that is required. So learners, this is how we use the equation of state for calculating or working out numbers like this. So with this, we come to the end of our lesson. We shall meet again in the next lesson. Thank you very much for attending.